What's up everyone, welcome back to this YouTube channel. Today in this video we are going to convert RGB images to grayscale images from scratch. We are going to look into the algorithm and the math behind this process. So without wasting any more time, let's get right into this video. So as you can see it on my screen, I am importing the imread from matplotlib.image and I'm also using the pyplot as plt and numpy as np. That's because I need something to read the image and something to display the image and something to manipulate arrays. So that's why I'm importing all these libraries. Next, you can see I have this sheep.jpg image. I'm going to use this image. You can use any other image that you like. So now we will begin by defining a variable input underscore image, and I'm going to set it equal to my image path, which is sheep.jpg. So before going any further, you need to know that an RGB image is an image that has three channels, one for red, one for green, and one for blue. And before doing anything, we need to separate all these channels. When we will have all those channels separately, what we can do is we can do a weighted sum of all those channels in order to convert our RGB image to grayscale image. And for doing that, we will use this formula. You can see we have some constants in there, and each constant defines the weight of corresponding channel and its impact on our final output. So let's first open the image. We need to say imread and wrap it around this sheep.jpg just like this. In your case, it might be something else. I'm using sheep.jpg, that's why I have written sheep.jpg here. You need to specify the path to your image file as an argument to this imread function. So moving on, now let's separate all those channels from this input image. So we can say r, g, p and do a simple array slicing to get all those channels. So I'll say input underscore image and I'm going to say colon, 0. This will give me the red image, the red channel, then comma input underscore image, then colon, 1. This will give me the green channel, and then again input underscore image, then again colon, 2. So this line of code here has separated all the channels from our original image. Now we need to define gamma. So I'll define gamma equals to 1.4 or 0.4, just like this. Then what we need to do is we need to define all those constants that we saw in that formula. So here are those weights of each corresponding channel. So this is for the red channel, this one is for the green channel, and this one is for the blue channel. So now we will apply that formula here. So I'll say grayscale underscore image is equal to, first we need to r underscore constant and we need to multiply it with red channel raised power gamma. Then we need to add it to green constant multiplied by green channel raised power gamma, just like this. Then we need to add it to the blue constant multiplied by blue channel raised power gamma. So we will get the weighted sum from this line of code here, and this will convert our RGB image to grayscale image, because this thing right here is only going to be one channel. It's not going to be in three channels. So now all that is left to do is to display this grayscale image. So we will use the matplotlib for that. So I'll say fig is equal to plt.figure1. Then I'll create some subplot. So I'll say img1 img2 is equal to fig.add subplot 1 to 1 fig dot add subplot 1 to 2, and finally I can come here and say img1 dot imshow. So I'll first display the input image and then I'll display the grayscale image, img2 dot imshow grayscale image, just like this. And then finally we can say fig dot show and plt dot show. Simple matplotlib stuff. You guys might already know all this. So this block of code here will display the image. This line of code is converting our image into grayscale image, and these are simply constants. This is the gamma value and these are the separate channels. So if we run the code, we should get a grayscale image. Okay, I forgot to add the CMap, so in here I need to say CMap. CMap is equal to plt.cm dot get CMap, and inside here we need to pass gray as an argument. So now if I run the code, we should get a grayscale image. You can see we have successfully converted our input image to grayscale image. Now coming back here to these constants, you cannot change all these constants, they need to be the same, but you can change this gamma value. So if we go all the way to 6.0 on this gamma, let's see what we get. You can see we get a darker version of our grayscale image. If we go to something like 0.4, let's see what we get. We get a lighter version of our grayscale image. So it's up to you what you want to achieve. For me, 1.04 works pretty good, so I'm going to keep it to 1.04. So let's see. Yeah, that's perfect for me. So this is it for this video. So I hope you learned something new from this video. Give this video a thumbs up. If you have any questions, you can comment down below, and do subscribe to my channel. It keeps me motivated for creating more videos. Thank you for watching. I'll see you in the next one. Till then, peace out.